So today we are doing molecular compounds and covalent bonding. Yes, we're still talking about covalent bonds. So the first thing you need to know when dealing with covalent bonds are what's called diatomic atoms. Diatomic atoms mean in nature that they come in pairs. They have, like when you have a bromine, you will never have bromine by itself. If it's by itself, it's going to be Br2. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine will never be by itself. It will always be at least at like an O2, F2. If it's not combined with any other elements, they will combine with itself. These are called diatomic atoms. Go ahead and write this down to turn it in, the diatomic atoms. This will be on your test. Okay, there are two types of covalent bonds. You have polar covalent, where electrons are not shared equally. And then nonpolar is when the electrons are shared equally throughout the whole thing. Again, VSEPR stands for valence shell electron pair repulsion. Basically, the idea is that covalent bonds and lone pair electrons like to stay as far apart from each other as possible under all conditions. This is because covalent bonds consist of electrons. You're just sharing electrons. And electrons don't like to hang around next to each other. Why? Because electrons are negative charge. Negative and negative don't like each other. Because they have the same charge, like charges will always repel. Positive, positive like to separate. Negative, negative likes to separate. This for rhyme. Linear has 2 and O. Trigonal has 3 and 0. Tetrahedral has 4 and 0. Bent planar 2 and 1. These are how many bonds are in each one. You're going to have to know that linear has 2 and 0. Just like up here. Linear looks like that. Trigonal, 3 and 0, trigonal planar is the official name. It looks like that. Tetrahedral, tetra means 4. So there's 4 bonds. Then you have bent, which is 2 bonds with a lone pair up there. So you have a lone pair up there. So it actually has 3 things going on, but only 2 bonds. Bent, nonpolar bonds, 2 things. But it has 2 lone pairs, pyramidal bonds, 3 things, and has 1 lone pair. You can memorize this song and sing it to yourself during the test if you need to. So, write down, are you going to sing the song or not? Answer me that question and turn that in. That's number 2. The second thing I have you do. How to draw an electron dot structure over a covalent compound. We've been doing that. Count your total number of valence electrons. Add or subtract for ions. Remember, positive you subtract, negative you add. You draw. You start with the middle, then you work your way outside, and you add electrons. Create double and triple bonds if your total number of valence electrons does not make everything happy. You need to make sure it stays happy. Okay. A Lewis dot for Ni3. You start with the N. Nitrogen has 5 valence electrons, so it's 1, 2, 3, 4, 5. And then you add, I go ahead and put my 2 lone pairs down, my lone pair right here. So I can add I, and I has 7 valence electrons, so there's no double bonds, and I is happy because you put 1, 2, 3, 4, 5, 6, 7, and all the pairs are together. Then over here, same, you start here, 1, 2, 3, 4, 5, 6, 7, all are happy. Then over here, you start here. I always start at the one to the left of the element that you're creating the bond with. 1, 2, 3, 4, 5, 6, 7. Again, it's happy. It's lone pairs. The way you look at it is how many bonded electron pairs? I have 3 bonded electron pairs. I have 1 unbonded. The shape, what does this look like? This will be, how many bonds do I have? I have 3, so it will take on the trigonal planar shape. Is it polar or non-polar? Well, the way you look at it is this eye cancels this eye out. But does this eye get canceled out? No, this eye does not get canceled out by this eye, so it's polar. If that makes sense. Because in I, no I, this will draw electrons this way. This will draw electrons this way equally because they're the same element. This will draw electrons this way, but there's nothing here to draw it back that way. That's why it is polar. Okay, CRBR4. C is always in the middle from the last lecture. You put your 4 lone pairs, 1, 2, 3, 4. The bromine has how many lone pairs? How many valence electrons? Bromine has 7 valence electrons. So again, you will have all single bonds because you start here, 1, 2, 3, 4, 5, 6, 7. However, that has the 1 from carbon, so it's happy. This one's happy, same way. This one's happy, this one's happy. So, how many bonded pairs? I have 4 bonded pairs. I have 0 unbonded pairs. The shape would be this one right here, which is tetrahedral because there is 4 bonds. Is this polar or non-polar? This bromine pulls it that way, this bromine cancels it out, this bromine pulls it that way, that bromine cancels it out. So this is non-polar. Okay, now O2. O2, oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. I always like to leave this open for the bond in the middle. Oxygen over here. 1, 2,